Hello, and welcome to Office Hours with Dr. Dan. I'm Dan. Today's question is, why do buildings sink or lean? The simple answer is that buildings sink because the weight of the building causes the soil to compress or consolidate. For our purposes, soil or dirt is composed of solid particles as well as water and or air. For example, in sand, the individual sand grains are the solid particles you can see when you go to the beach. For clay and silt, the individual solid particles are generally too small to be seen with the naked eye. Consolidation causes air and or water to be forced out of the soil so that the individual particles can take their place and form a denser, tighter configuration. The densification causes the vertical dimensions of the soil to decrease, and whatever is supported by the soil will move downward. Buildings lean when the amount of consolidation is not the same beneath the entire footprint of the building. There are two main reasons for non-uniform consolidation. The first is that the composition of the soil is not exactly the same beneath all parts of the building. Soil is a naturally occurring material and can be highly variable depending on how it is formed. Slight variations in soil layering and composition can cause one side of the building to settle more than another. The second reason is that the load applied to the soil by the building is not equal across the foundation. Some column loads are greater than others, so the soil beneath the more heavily loaded portion of the building may consolidate more than beneath another portion of the building. Soil can also consolidate if the groundwater table is lowered either by natural means or by pumping. Soil below the groundwater table is submerged and has buoyancy. The amount of buoyancy is equal to the weight of the water that is displaced by the soil. Buoyancy is the reason that ships made out of steel can float. Lowering the groundwater table makes the underlying soil feel like a new load has been applied. This increase in what is called effective stress can cause consolidation, which can lead to the overlying building settling or leaning. An analogy for soil buoyancy is the bench press. Now, I can't claim to be an expert on the bench press, but there is a gym next to one of the donut shops I frequent, and I've seen people doing this exercise through the window. Sometimes when a serious weightlifter is getting to the end of their set, they employ a spotter to help get a few more reps. The weightlifter is still doing most of the work, but the spotter is helping by lifting some of the weight. The spotter is analogous to buoyancy. It takes some stress off the soil. If the spotter goes away or isn't paying attention, the weightlifter will have to do all the lifting, just like the soil has to do when the groundwater table is lowered. Engineers can estimate the amount of consolidation that will occur when a new load is applied to the soil, but it is just that, an estimate. Variations in the soil and limitations of soil investigation methods mean that sometimes things go awry. Usually this is bad and leads to unwanted attention by creatures of the night called lawyers, but every once in a while a settlement failure turns out to be beneficial. After all, would you have heard of Pisa, Italy if it wasn't for its famous leaning tower? I hope you've enjoyed this simplified explanation of consolidation with its rudimentary graphics. Please check back for future videos on engineering topics, as well as my advice videos for college students and professors. Take care, and I'll see you next time.